Uh, hey guys, how are you? It's been a while, been in a conference. Like I think last time it was React Nexus, and it's been a year, and I'm coming back. So today the talk is gonna be okay. What happened? So while the technical glitch is getting resolved, so tell me, like, let us bitch about the coding agents, so which I have been known for in the React meetups. So, how many of you are using the coding agents? I think as the inverse. Is there anybody doing without the coding agents? Probably not. Okay. So, what is the coding agents painful part when it comes to the UI? Right? While in the meantime, like while this is getting resolved, I can talk about it. So, in a React or like any front end apps, the critical part is the debugging or like giving the agent the runtime context, right? Say if it is a backend engineering thing, like if there is any system that you're running, so it's very easy, right? To get the logs, it will be written on your local workspace, and it's very easy for Claude or any coding agent to go get that and then debug, fix it. But when it comes to the like front end apps or like anything related to React or any front end apps for that matter. So you cannot actually give the agent the ability to see the logs, right? Why? So basically, the logs are inside the browser process, right? Like if you're using Chrome, Chrome has all the logs actually. So it is not like the actual well, like he opened the wrong slide. Okay, go to the first one, please. I'll get. All right. Thank you guys for resolving. But yeah, uh, let me complete what I was speaking. Uh, so the thing is like we need that debuggability so that you need that visibility to the logs, and like for that, like what people were probably using is writing their own CDP script and things like that. And that is where like this project called dev3k comes into the use, or like it will help you. It's from Versal. You will see me in that community very active also. Like I've been fixing issues, delivering features in that dev3k open source project. Just try it out. It's very experimental at this point. Like we'll be like, I think we are still on the zeroth versions, but still we'll be going ahead and then building this version, delivering it. So coming back to the talk, this talk is going to be on the Playwright MCP. So I'm Santosh. I work for this company called Bracket AI as a founding engineer. So anything related to the UI, AI, data, agentic systems, whatnot, coding agents for that matter. So you can catch up. These are my socials. So first, like, what is MCP? Like, I think it's a very vague question for a crowd where there is nobody who doesn't use a coding agent, right? So, model context protocol, and like, it's just like helps you to connect to any external systems from your LLMs. As simple as that. So, now, why MCP matters? Right? So there are other ways, right? So agents or like coding agents or any LLMs for that matter, if you're giving it a process on your local machine, right? So it can do anything, right? Like meaning what I mean by anything, it can run bash scripts, it can use your CLIs, like it can just how you do cat, it can do cat and then see the file. How you actually go ahead and then write the file, maybe using a VI editor, it can also do the same. Or if you are just trying to write a file, like echo it, so it can do the same. So whatever a human can do with the machine, if the agent is provided with the same machine, it can also do. Simple as that. So now, why do we need the MCP at the first place, right? So two things. One, if at all the user or like the agent want to connect to some external systems, right? Say for example, I'm running on a like GitHub, like I'm just pulling the code from the GitHub or pushing the code to the GitHub. So there are two ways primarily, or three ways primarily. Like I can use the APIs, like get the things done by using a curl command, like use a bash script. So, but that is not native, right? Like it need to first construct that API, and it can make mistakes in constructing that API calls and things like that. So now the second thing, what it can do is like use the CLIs, like curl or something like that. Like that can also happen, or use the Git CLI, which is like a wrapper around whatever they have already. But there is a third thing that they can do, which is using the GitHub MCP also, right? Like, so that is where the benefits come in, where the agents will have structured responses, and it can also request in a certain way. So the thing is, like, we all like structures, right? Like, meaning we all like a formatted way of communication, right? Like, if it is HTTP, like a normal web call, we usually go with a HTTP call or something like that. So the structures give better understanding for the agents also. Now, the second side is host side execution. Like I don't run everything on my local machine. There is a lot of things offloaded to be run on the GitHub service. For that matter, if I want to search something, I would probably search on the local machine in most of the cases. But in case of MCPs, you can delegate it to the MCP server and then get the things done. And then the standard authentication. So basically, every CLI, if you take to think of, like there are tons of CLI, curl, git, whatnot, like what are all the other CLIs that you use, you name it, and then that will have its own authentication. Like some use API tokens, some use API keys with the secret key, and some may use something different also, right? Like a proper OAuth. But with MCPs, the connection, the authentication part is like simple, standardized. Everywhere it's going to be OAuth, so it's all standard authentication there. So, but the most important part is the fourth point, right? Better governance. This is not something you can get it from the CLI or bash scripts or anything, right? So your security is taken down when you're using a agent directly on your local machine. So what I mean by that, right? Like harness is something that you need to give, you need to build around the AI agents to operate in a most secured way, right? So that is where the MCPs comes into the play. You can just govern it, like say this commands you can run it, this commands you don't want to run it. For a particular project, think of I don't want to push it to the GitHub through MCP servers, but I can just keep pulling the things. So what I can do is I can just mention it in the CLI and then just keep pulling but not pushing, right? Like I can, it's just a single JSON modification config. And then once the config is updated, that harness is automatically embedded into your systems. Instead of, if you think of CLI, like I give that enforcement should happen only on the server side, and then like what happens is like the agent will still try to push the code and then it will fail. There is no like a harness layer inside your local machine to harness what the agent is doing, right? But given all these benefits, there is a problem, right? So what about the token expense? So given like there is a 1 million context for Claude, like what is that, Opus now, like probably people do not worry more about it, but still it takes 17K when it comes to the Playwright MCP, right? Like specifically to the Playwright MCP, not MCP on the whole. Like Playwright MCP takes like 17K tokens at the startup. Once you register, once you start your Claude session, it just takes up that 17K. So it's unnecessary token. So now what are the other alternatives, right? So Playwright MCP is again like Playwright is just like something which helps you do web automation, and then MCP we were explaining till now. So like enables you to do web automations from the agents directly. That's what the Playwright MCP is all about. What are the other options if MCP has this token issues? Can it be solved? Yeah, it can be solved. So they have a CLI. You can use. You can always use their libraries, the executables, and things like that. So there comes the difference, right? Like say the token expense is less for the CLI. It can run headless, but the MCPs are always headed. It can run only headed Chrome. It cannot run headless Chrome. So it runs on low CPU, low memory, fast as well, obviously. So all that is required is like a one npx command. Like it's a simple runner. You can just directly run it and then get it up and working. So, but still, why MCP is required? So here comes the problem, right? Like, so MCPs has this unique advantage of like the agent being part of the agentic loops. What I mean by that. So let's consider I write a Playwright script, right? Like for that matter, like let's consider like I am as a person writing the Playwright script. Something fails, I'll wait for it to fail and then go back, we understand like what has gone wrong, and then again fix it, again wait for it to run, again go do that. So this is a loop, like meaning this is like a big loop, meaning I write it, execute it, come back, debug, fix it, do that same again. So now if you think about MCP, where it does better is like it goes one step at a time, right? So it will just do, okay, now navigate, see the page is loading, okay, it's loading, now go back, see like if the button is clicked, it's clicked. So now it exactly know where it failed. Like at consider like it's a 10-step Playwright script, which may grow up to like million lines also, million steps also. But think of that, right? So that is a problem. And then think of the app awareness, right? Like if you are running through a CLI, you will not get all the details and things like that. But MCP can even read your console, it can read your data, what is there in your extension and whatnot, right? So Playwright MCP has all these benefits. Now, the co-location paradox, that need not be there when it comes to the MCP. What I mean by that? So your agent runtime and then the CLI runtime both should be running on the same machine when it comes to the CLI or even bash scripts. But with MCPs, you don't want that. You can run it on a separate machine, separate pod in your Kubernetes cluster, and then just make sure you are able to get the data from the running thread for that E2E pipeline or whatnot. And then the enterprise security, as I mentioned, like whenever you are co-locating it together, think of you are almost exposing all of your data to the AI agent also. It can do, like it may not do, but it can anytime go ahead and then do that. So that is another thing that you need to be worried about. So now we knew already like there are these many benefits, but is it convincing to run it on a nightly build? Probably not. It's not worth it. So why it's not worth it? So every time when you run it through MCPs, it is expensive with the tokens, right? Like meaning not real expensive, but still when it comes to the pipelines, like which is gonna run every night, so it's gonna grow exponentially when your product grows and then the Playwright script grows, the surface area grows, everything, right? So everything adds up. So why we don't want to invest there much, basically because it can just be done with a CLI which can do mechanical things. Why do you need AI tokens to be expensed or like even spend more time doing the things which can be done mechanically, the single script? So where do I use it? And again, it's also non-deterministic, right? Like you also understand, so AI can verify things, but it's not deterministic. And I also feel like the talk is very poised at the right position. I think the previous talk was on the similar note, right? Like using AI for testing of sort. Like it can test. It can test up to a certain limit. There is a limitation, right? Like 80%, 90% accuracy, something. But once the things are fixed, the exploration is done, this unnecessary token usage or non-deterministic testing doesn't make sense. So you would probably try to run this Playwright script like nightly instead of running a Playwright MCP with the agentic testing nightly or sort. Maybe it can be used in some peculiar cases, something like say you have a third party integration, you don't want, and the things are moving fast in that integration also, and you don't know like how it's going to work. So probably you will delegate it to the AI and then see how it works, but still it will not be deterministic. So that's the thing. What are the ideal use cases then? So you use it for once the E2E fails, why do a developer need to go and check it, right? Like you can write a pipeline which can be triggered internally, which can go and check the E2Es why it failed and then fix it, right? To fix it, then it requires that MCP support so that it can understand the things better. And then as well as the bootstrapping of the test cases. Like when you write the Playwright scripts for the first time, it's going to be like a lot to your head, right? Like meaning you need to understand the app, you need to write it in the Playwright script, and then you need to architect the test framework also well so that it scales and it's not taking a lot of time. That is where the MCP solves the problem, where it comes under the agentic loop and it's not actually burning out all the resources, right? Like it actually like it almost reduces all of your efforts. It just goes, explores, and understands, and then writes the script by itself. Let's just see a quick demo of this thing. Like, let me quickly go over that. So I have built this quick app, like just like you can add like buy groceries. It's just a simple app. So I can add it to the checklist and then mark it completed. I can see the filters and all these things, and I can delete it also. Simple as that, simple functionality, right? So now if I want to write a simple, okay, so this is how the MCP is connected. Like it's just a simple JSON. Like I have added it like .mcp.json. So it is helping me just connect to the MCP automatically whenever I'm just like in this thing, right? Like meaning whenever I open the Claude session in the current working directory where this mcp.json is present, it automatically connects to the MCP. So now what I need to do, like I'll just check whether the server is running. It's running. So I'm just gonna add a simple prompt so that I can show a working demo. Okay, so now it's gonna just go ahead, open up a Chrome instance automatically. Now, see, Playwright is running. So you can see the Chrome coming up. This is like automatically doing. The agent is understanding, like I can open the logs also here. So you can see the Playwright MCP is getting called here. You can see for every time, like it's trying to add a new to do. It's understanding where the to do input is. It's trying to paste the input, clicking on the submit. So all these are done by itself just by a simple prompt, right? Like for these kind of exploratory stuff, it's better to use MCPs and not for mechanical stuff, right? So now I have just asked it to just verify a couple of features. It verified, right? So now let's try out one more thing. Let's ask it to write the test by itself. So if you see the test doesn't have anything, you will see the test getting written now. So it's just gonna test out the same thing which it did. Like it's just gonna add like some couple of to do items and then try marking it completed. So it is written. Now I can go here, npm run test. Yeah. Let me close it. Okay. So it is having some errors. We can let it fix also. So anyways, keeping that aside, so this is where the Playwright MCP comes into play. You can help it, like meaning it can help us debug and then fix the E2E tests by itself instead of actually running the E2E test by itself. So that's it. I think you can see my code here. Like, thank you so much.